This is going to be an aid. Hello, everyone. This will be an aid to those that are GNATS, which is go now and teach someone based on some of the stuff that we did here. Let's see. You review. Start. So GNATS, go now and teach someone. All right, regarding the calculator and Wolfram. And I'll use Wolfram as a general statement for what is going to be alpha and Mathematica. Okay, and so there'll be a number of these throughout the semester as I miss a day for the kids or whatever else, and we'll kind of be sliding this calculator stuff. And so we're going to really concentrate in the short term on the calculator and get you kind of started with some of the general bits. You turn it on. I've got a lot of stuff in mine already. This is actually an emulator, and so I've got programs on there. But what you really need to do is the first thing you do when you turn on the calculator is check something you know, the tangent of 45, and soon also the sine of 45, and the cosine of 45. All three of those you should know. Well, actually only one you really know. I'm going to go over here to the right side and remember that in fact when we went and looked up at the North Star, right, if that's a 45-degree angle, then you know this over that's the same, and the tangent is the opposite over the adjacent. But that's not how we're learning it. We're learning this way. In a circle, pick a point there at a 45-degree angle. This over that times that equals that. And then we are also learning, and some of you will see that very quickly, that if we divide this at 45, at 60, and at 30, we know that the coordinates on the circle are in fact 1 and 0 here, 0 and 1, and we know that we have ordered pairs here in those three, which of course are 45, 30, and 60, or pi over 4, pi over 3, and pi over 6. And we remember the over 2, over 2, over 2, over 2, over 2, over 2. Sorry. 1, 2, 3, 1, 2, 3. Square root of 1 is 1, square root of 2, square root of 3, square root of 1 is 1, square root of 2, and square root of 3. So I'm going to go ahead and just see if this eraser works on this thing. It's supposed to. Kind of trying to do the eraser thing here. So we're going to remember that we're going to know by rote the tangent of 45, the cosine of 45, and the sine of 45. And sooner or later, you'll realize that there's going to be triangles coming at you and sines coming at you, but the triangle is based on if this is 1 and this is 1, which a 45-degree angle has, 45. This is the square root of 1 plus root of the square root of 2. The tangent is opposite over adjacent. The cosine or sine are 1 over the square root of 2. So and so 1 over the square root of 2 is the same through as the square root of 2 over 2, I think. Let's see. 1 over the square root of 2 is 1 over 1.401, which is 0.707. And the square root of 2 over 2 turns out to be the same. So don't get confused in that. All right, once you've done that, you still want to go ahead and check the mode. So you click on the mode, turn your calculator on, turn the mode, and you have then float, which you can set normal float, and you can set float to around 2. I'm clicking down and over. Maybe, this is you're going to be changed for different classes. Radians or degrees is the key here. If it did not come the way you expected, you probably didn't have it set degrees. Functions, parametric, polar. And we'll just tend to keep all of these kind of black. You check the screen, you know what you're doing there. First thing you do is check the mode. We learn to hit second quit. We learn to hit clear. We want to then check that our graphing stuff is set up correctly. We do that by going to the y and putting in something we know what it looks like, and that's y equals x. But very quick, we don't want to put just y equals x. We'll change it out in a little bit. And then you're going to go and hit maybe second quit and graph. And you see something like that because you don't have things set correctly. So besides setting up your mode, you want to set up your window. And what we want to remember is that our window should go from, the x should be 1.5 times the y. So we're going to go from minus here, let's say, minus 200 to 200 for maximum x. And x scale can be anything you set, but basically somewhere around 10 or... Now if x is 200, y should be 1.5 times that. I'm sorry. As x is 150, y should be a 100. So I'm going to go back up and do that here. And the reason why you're doing this is you're trying to set it up so a 45-degree line looks like a 45-degree line. From minus 150 to 150, and remember you have to use this for the minus. You can't not use the subtract key. Same thing there. And your y is going to be 100. Again with a minus to start. Minus 100. Max is 100. Y scale is 10, the resolution is 1. These are going to look different on different calculators, but once you've done that and hit second quit and hit graph, you can see you've got that 45-degree line. Now I've got some other things going on, but that's what you want it to look like. I look at here in the Y. The other thing you want to look at, second stat plot. You would like stat plots to be off. We've had that problem in class already. So you want stat plots generally to be off. That's why you saw that other bit. Second quit, clear, graph. And so now you've got that. We also did something in class in terms of having a circle, draw a circle, but we're not going to do that here. We are going to show you, like we did in class, how to do polar equations and potentially parametric. So we've learned that we have to set the mode, we put things in, and when we put our formats in, we don't put y equals x, even though we like that. We do y equals 1, x plus 0. If you want to keep these standard formats, so when we do graph, it looks like that. So when we go back to y equals, maybe we want to not use 1x, we want to use maybe plus 20. And we hit graph now, and you see how that line shifts from underneath there. Go back to y equals 1x times plus 20, which is the slope intercept. Put that back to 0. You're going to graph a number of different things. We learned in class the fact that sometimes you can actually put halves of circles in. And I think, well, we'll do it over here right now. The sense of the downfall of this computer or this calculator, and the reason why we have Wolfram Alpha down here is that it does not do a great job and over here on the right side now, it does not do a nice job in just letting you put any standard thing in standard format. So we should quickly know that the equation x squared plus y squared equals r squared is a real standard form of a circle. However, it won't let us put that in here, so we can put half a circle in there by doing this. Remembering if we take x squared plus y squared, let's say equals 25 squared, and we want to solve so it can be in the format y equals, we turn out to be something like this. We subtract minus x squared from both sides, and we end up with y squared equals 25 squared minus x squared. We take the square root of both sides. We take y equals actually plus or minus, but the square root of 25 squared minus x squared. That's what that equation looks like. And how does that look like? It's kind of weird when you put it in there and it'll only graph for half of it, but you do it this way. Open parentheses. 25, if you would, caret squared plus x squared, close the parentheses to the root of 0.5 because the square root is something to the 0.5 power. And now when you hit graph, you should see portion of that circle, though it looks a little odd here. And we're going to go back to y equals the square root of 25 squared minus, if you notice there, that's what I messed up. You're kind of visually looking at, that should be a minus there. I'm going to do insert, shift insert, and you're going to put a minus. And now when you graph, you should see that little half circle there. Okay, the final thing we did is we looked at polar graphing, because we're going to look at parametric at another time. So when you go back to mode here, not only do you have an ability to put functions, we have an ability to put polar and parametrics in. So I'm going to go down to here and go to polar. And usually when you're going to polar, you're going to go up and put things in radians. And so now you got things in radian and polar. And now when you go to y equals, you see nothing blank. And you can start with y equals 100. And go back to the window and see that it's going from 0 to 2 pi. And it should fit when you hit a graph here. And you see that circle. What you're trying to do when you draft y equals x or y equals 1x plus 0 is to make sure that your coordinate system is reading true, that you are not screwing up your eye. Once you're there, you can do all kinds of different things, but you can graph more than one function. So you can put basically r equals, and we can learn that this function here is kind of like the magic button. The radius equals the angle, and so as we go here, or maybe the we can do the angle times 8 or whatever. And when we hit graph here, you should see a couple of different things. Back to window, you see that this actually tells you how many. This is going to go around once, so you can go down in here and maybe make it, instead of 6, you might say a little bit more than 3 pi, and hit graph, and you can see that's going to go a little bit farther. Whoa! And you're looking at some pretty cool stuff. And so that general bit of how you're going to basically do a couple of things. One is you are going to get really good at using the mode key and checking it early and often, using the y equals in any set format. And the y format comes from what is set in the mode. So if I go here, second quit, change the mode back to function, what I see then in the y equals is my basic equations I've got there. When I do the graph, basically you can see that general circle. You are going to want to learn to actually stow things. Remember, I'm going to erase this out one more time. There are a number of different variable types in a calculator, and you're using them already. You're using lists with Greg and a few others. Lists are great for the stats, but you're going to want to clear them out of your L1, L2, L3 so you don't have issues. Sorry about all the dinging, dinging, dinging. Boy, that's obnoxious, huh? But remember, variable types. There are real variables. They have single letters. There are lists. And lists are denoted when you make them by the squigglies. And these are the ones you can give a long name. You can give a long name. We have matrices. Okay, from the matrix. And then we have character. And in many programs, you'll have either logic or, let's see, real, list, integer. So these are all these things that you can be using. We'll be building up. The reason why we left Wolfram Alpha up here is because there are some things that, this is not the best graphing engine. We have Wolfram here, so you can do things like this. Almost run out of time, but you can say something like plot x squared plus y squared equals 25 squared, and you'll hit an equal sign here and it will graph it, though sometimes it will screw up your axes. So I'm going to kind of extend this out a little bit, and there it is. It just graphed it up. And you can very quickly realize that you can start playing around with these graphing engines, and you'll start to recognize if I said plus 60x and plus 50y, that's going to be also a circle. It's just going to move. So I'm going to see what that happens when I graph that. And we're out of time. You should see it when it comes in. You see it, and it's not really an ellipse. It just looks it that way. Thanks for listening. Go now and teach someone.